Good morning, students. So let's start our class today. I'm going to share the screen with each one of you, and you'll be able to view it shortly. So today, what we'll discuss the assignments what I gave yesterday. So we will discuss the solution to those questions. I do understand. Few of you told me the questions are relatively difficult. So we will go through each of these questions. We'll understand, how to proceed, and most importantly, how we can leverage our existing knowledge. The questions become difficult if I do not know the concept behind to solve it, or if I do not know the relevant theory behind it, or if I do not know the relevant formula to solve it. But if we have all this knowledge, ready, and we discuss this thing, then it is very important to know that how to, apply those formulas, knowledge, and simplification of different expressions in complementary manner to achieve results. So with this, I would like to first discuss on, let me put, make the question available to you. I hope that was the first question, dear students.
Yes.
Okay, so okay, let me do one thing. Let me, pull the question properly. Just a minute. Today we'll be discussing these questions only. Okay. So this is question number 1. The first question. So, I want to know from each one of you how you actually, approach this problem. The first
So
one.
I made log x equal to t.
Correct. You are.
Then I got then log x equal to t. Then dx by x becomes dt. So I get dt by t to power m.
Yeah. So, yeah, absolutely correct.
And then we integrate t to power minus m and
Correct. So, what is your final answer, Devanshu?
log x to power minus m plus 1 by minus m plus 1.
Plus C.
Yeah, plus c.
Yes, even I got this.
All of you got it?
Yes.
Disha, Srijita,
Yes, sir.
Mohur, all
Yes.
of you got it? Okay. Okay, great. Now let's come to the next question. And in next question, okay. By the way, if if you apply m equal to 1, if you apply m equal to 1, what you will get? You will get integration dx by x log x, right?
Yes.
So that is also a very important integration sometimes comes in the question. So there you need to apply, just in your result also you need to apply m equal to 1, right? So in that way you'll not able to find, because if you get that m equal to 1, so that becomes 0 in the result I'm talking about.
Yes.
Anyway, let's proceed to the next question. Next question, how we have done.
Sir, I multiplied the numerator and denominator by root x plus 1 minus root
X plus a, I hope.
Yeah.
Yeah, I basically rationalized it.
Correct. Absolutely. In single word, the truth is that rationalization of the denominator.
Yeah.
If you rationalize the denominator, so what happens is that you get something like this thing, square root of x plus a. So if I take this one, if you rationalize, so that will become integration square root of x plus a minus square root of x plus b, correct or not?
Yeah.
Yeah.
Divided by a minus b.
Yes, sir.
Correct. So after that, it is pretty simple, correct or not?
Mm.
All of you got it? Because
Yeah.
what we'll get after that, all of you got it or not?
Yes.
That is, we can take 1 by a minus b common. Let me inform it for everyone's, information. Square root of x plus a dx minus integration square root of x plus b dx. So how to find square root of x plus a dx, Disha?
Square root of x plus a dx is equals to x plus a to the power half.
Correct. Go ahead. Yes, you are saying correct. You started saying correct.
So then it is equal to x plus a to the power 3 by 2 by 3 by 2.
Fantastic. And all of you understood, right, why it is so? So it is x plus a power 3 by 2. Srijita, you understood why it is x power a plus power 3 by 2?
Yes, sir.
Minus 3 by 2. Minus here also. Here it is x plus b power 3 by 2 divided by 3 by 2 plus c. And after that you can simplify. I'm not proceeding. I'm not spending time on that. That how to simplify. It is quite easy. And as we discussed in the first question, so it should be, your substitution should be, log x equal to t, and proceed. Fine. So now I think we can proceed to the next question. Correct?
Yes.
All right. So this is question 2. And dear students, please do let me know how you approach this problem. I want to know from each one of you. After that, I'll provide my solution.
Sir, I multiplied and divided by x plus 1 to power 4.
X plus 1 power 4.
Yeah, and I took out the one, to the power 1 by 5 outside. So it became x plus 1 to power 10 into x minus 3 to power 4 by x plus 1 to power 4 whole by to the power 1 by 5.
Okay, so what you are going to achieve out of after that means, if you
Yeah, so after that we since we have x plus 1 to power 10, then 10 by 5 will become 2. So then it will become x plus 1 to power 2 into x minus 3 by x plus 1 whole to power 4 by 5.
what is your final answer? Let me understand your
5 by 4 into x minus 3 by x plus 1 to power 1 by 5 plus c.
perfect. That is correct. Okay. So initially what you said, all of you got it, or do you need someone needs explanation from me?
So I didn't get it.
Okay.
So I got it.
Yes, sir.
Okay, definitely. I'll assist you, Mohor. And Disha, Srijita, you got it?
So I didn't get it.
Okay, let me explain.
Yes, sir.
Okay. So how to proceed is that one thing is that first thing what we need to do is that integration dx. I am not writing anything on x plus 1 power. But before that, as between 4 by 5 and 6 by 5, 4 by 5 is smaller than 6 by 5. So what I want to write first is that I want to write x minus 3 by x plus 1 power 4 by 5. Correct, no, dear students? Then what we'll do here? Here it will be x plus 1 power 6 by 5 minus 4 by 5. 6 by 5 minus 4 by 5 is what? Tell me.
2 by 5.
2 by 5.
Yeah.
Okay. So then what we are going to do is that here we are going to get it is 2 by 5. Correct or not?
Yes.
Okay. So here it is 6 by 5. Just a minute. 6 by 5 and plus 4 by 5. So it will be here. It has to be 2. Correct, na?
Yes. Yes.
So it is x plus 1 power 10 by 5 minus 4 by 5. That becomes 6 by 5. All of you got it?
Yes. Yes.
After that, what we'll do? After that, we'll take a substitution of x minus 3 by x plus 1 equal to t. Correct, no? Why so? Because we know if we make a differentiation of both the sides, so what we'll get? We'll get that 4 by x plus 1 whole square dx. 4 by x plus 1 whole square dx is equal to dt, correct or not?
Yes. Yes.
So that means 1 by x plus 1 whole square dx equal to dt by 4, and that's what we should write here.
Okay. Okay.
1 by 4 integration dt by t power 4 by 5.
Yes.
After that, it is quite simple.
Yes. Yes. Again.
So it should be t to the power minus 4 by 5 plus 1.
Yeah.
4 by 5 plus 1 means what? 1 by 5.
Yeah.
1 by 5 will go up, so it will become 5 by 4. 1 by
Yeah.
4 to 5 by 1, na?
Yes. Yes.
5 by 4 into t to the power 1 by 5
Yes.
plus c,
Yeah.
where c is integrating constant.
Yes. Yes.
Dear
Understood.
Tisha, you got it?
Yes.
Okay. Integrating constant, and then finally we'll apply the value of get back the value of t, that will be 5 by 4 into x minus 3 divided by x plus 1 power 1 by 5 plus c. So what is the lessons learned? If you see, if you look into this question very minutely, this question is not belongs to integration in that way. If you see what I have done a proper transformation, and after that a substitution. Correct, no?
Yeah.
Thing is that whenever you get this kind of rational power of algebraic expression, first you think that okay, between here in this context of the question 6 by 5 and 4 by 5, so I can make x minus 3 by x plus 1 power 4 by 5. Oh, okay, then what will happen? Then x plus 1 power 2. Can I make the substitution? That is what, as I said yesterday, you want to think 2 steps ahead. I'm not telling that you need to think about 5 steps ahead. Yes, you can think of, but not today. After good amount of practice, you can come to that level. But that is what is required. Recall yesterday, the ones who was asking one question that I divide ln x problem. So, so same thing, you can think about, but whatever you come to your mind, do not apply accordingly unless you get a proper justification. You could have said, no, sir, I want to divide x plus 1 by x minus 3 power, 6 by 5. Then you may not able to achieve this result. No? Those steps are correct. Correct doesn't mean that it is effective. Okay. So now let's proceed to the next question. Sagnik, you got this problem, na? You said, right? Gurman?
Yes, I got it.
Yes.
You got it, right? Okay, okay,
Yeah.
great. Okay. Now, next problem. This is a very important problem, and I can guarantee you one thing. This particular question, you will definitely get, okay, in the next 2 years in some of your exam. Either is your board exam or your school exam, or there is a chance in the entrance exam, but that is not up to JEE main, but in Karnataka CET or state level engineering entrances you may get, but definitely will get. Okay, how many of you are able to do this one?
Yes, I got this one.
Very good, appreciate, fantastic. Okay, Sagnik.
Yes, I got an answer, but I'm not sure if it's right.
Okay, no problem. So you got an answer, that is important. Right or wrong, that we'll see as this goes by, and that also a little bit defined by your confidence. What is your answer, by the way?
So I got 2 sine inverse of root x minus a by root b minus a plus c.
Yeah,
Yes. Yeah,
it is.
even I got that one.
It is such a correct answer. So why you think that whether I do not know whether it is correct or not? Absolutely correct answer. And if you recall, I think this substitution I mentioned in the table, right? Whenever you get x minus a into b minus x. Hello, Mohor, Disha,
Yeah.
Vijita, you got it? Gurman, you got it?
So I got stuck, like I did 5 steps and then after that I didn't know
Okay.
what.
What was your steps, by the way? Means how you proceeded.
So I got it.
You got it. Great. Mohor, how you proceeded?
Like I expanded the denominator
Okay.
and then like I took like x square minus x
Yeah.
into a plus b
Yes,
plus.
you can take that approach. There is nothing wrong, but it is a little lengthy approach. Means you are telling that denominator I am making it the square root of a quadratic expression. Then
Yeah.
I'll know that that the formula I know x square minus s square or s square minus x square. In that way I will do. Correct, no?
Right.
Yeah, that is not a wrong approach. That is definitely a correct approach, but that is at the same time is not a very time efficient approach.
Okay.
Okay, so how to apply this one is that there is a substitution. If you apply that substitution, so this is question number 3. If you apply that substitution, then you will find this is becomes so easy. The substitution is that a cos square x equal to a cos square theta plus b sine square theta.
Yeah.
So let x equal to a cos square theta. Remember this thing. This, as I said, this will definitely come in some of your examination in the 2 years tenure. B sine square theta. Correct. So then, what will happen about the dx? We can find the value of dx. Correct or not, dear students? So dx will be what? So we can find it out quickly. Dx equal to here it will be minus 2a sine theta. Correct or not? Then, correct or not?
Yes.
Minus 2a into cos theta into sine theta.
Yeah.
And here it is 2 into b into sine theta into cos theta. Do you agree to me?
Yes.
The whole d theta. Correct, no?
Yes.
Whole d theta. So from here what we can get is that dx equal to, we can write that 2 into b minus a, 2 into b minus a into sine theta cos theta d theta.
Yes.
So let's apply here. So what we are going to get then? If we apply this one, then what we are going to get, instead of dx we write 2 into b minus a into sine theta into cos theta into d theta divided by square root of x minus a. X is what? A cos square theta plus b sine square theta. Correct or not?
Yes.
A cos square theta plus b sine square theta minus a into b minus a cos square theta minus b sine square theta. Not. So, so entire thing power 1/2.
Yeah.
Correct or not?
Yes.
So now we can simplify this thing further. So if we simplify, so what we are going to get? So 2 into integration, what we are going to get is that 2 numerator to as it is 2 into b minus a into sine theta into cos theta into d theta divided by, you see, a cos square theta minus a. So that becomes what? A into
Minus.
minus a cos square theta. So correct or not?
Yes. Yes.
So b minus a into what you get? Sine square theta. Correct or not? Again here it is a b minus a sine square, cos square theta.
Yeah.
Then square root if you remove, then finally you will get b minus a into sine theta cos theta. Are you getting my point? Because it is power 1/2, na?
Yes. Yes.
All of you got it, dear students. Disha, you got it? Srijita? So then what will you do?
Yes, sir.
Okay, then 2 integration d theta. It is so simple now, correct? Since b minus a cannot be equal to 0. 2 into d theta. So 2 into d theta means what? 2 into theta plus c,
Yes.
where c is integrating constant. And 2 into theta. So theta is what? We can, revert back the value of theta then. So we can find the value of theta from here. Okay. So if you see here, x equal to a cos square theta plus b sine square theta. So from here we can find the value of theta in terms of x. How?
Yes.
Because here we can write that cos square theta is equal to 1 minus sine square theta. Correct? So cos square theta equal to 1 minus sine square theta. So then it will get x minus a. So let me do it quickly. So it is simplification, very, very easy simplification. Because directly you cannot find the value of theta in terms of x, na?
Yes.
So what we are going to get it here is that x is equal to, or let me do this place. Let me not do it here. Let me do it here. So what we are going to get is that this implies x equal to a into 1 minus sine square theta. So a into 1 minus sine square theta plus b into sine square theta. So from here what we get is that b minus a into sine square theta, b minus a into sine square theta is equal to x minus a.
Minus.
So from here you can get that sine theta is equal to, you can write sine inverse of square root of x minus a divided by b minus a. Correct or not? And that value of theta we should apply back here. Correct or not?
Yes.
And what we are going to get then? 2 into sine inverse square root of x minus a divided by b minus a plus c. So what is the lessons learned in this question is the proper substitution. And if you are not able to do the substitution, that substitution formula is there in the table what I mentioned earlier. If you are not able to do the substitution of, or you forgot what to substitute, then Mohit, the step what you applied is fine, but you need to proceed. Okay, because it will be a little relatively complex algebraic expressions.
Yeah.
You need to proceed with patience and with full concentration. We should not lose track. That's what I'm want to say.
Okay.
Anyway, let's proceed to the next question. What I gave, the questions will be available to you shortly. This is question number 4. Correct, dear students?
Yeah.
Yes, sir.
So, how you approach this question?
Sir, I took t square is equal to x cube. Then t is equal to x to the power 3 by 2.
T equal to what? Sorry, Divanshu, tell once more.
I took t is equal to x to the power 3 by 2. Basically, t square is equal to x cube I took.
Correct.
Yes, I did the same.
That is the right approach. Yes. So,
And then
yeah, go ahead. Now, as the integral, what motivates you to take t equal to x to the power 3 by 2? Dear Sagnik, did you get it? Sagnik, Guruman, Disha, Srijita, all of you got it?
Yes, sir. Good.
Okay. So, the point is that if you see the integral of the numerator, as the integral of the numerator coming x to the power 3 by 2 by 3 by 2, isn't it? What is the integration of x to the power 1 by 2? It is x to the power 3 by 2 by 3 by 2.
Yeah.
And that actually helps us to take, let's take x to the power 3 by 2 is equal to t, so that in the denominator, in that term in x cube, I will get actually t square. And we know the formula of, that a square minus t square. A q though we will manage it, not a big problem. A to the power 3 by 2 power square. That's it. Correct, no? If someone is not able to get it, so I can do it for you. So here it is. So as Divanshu, you said correctly that I took the substitution x to the power 3 by 2 is equal to t. That is correct. But I was telling why it is so. So we are taking let x to the power 3 by 2 is equal to t. Then what we are going to get is that square root of x should be equal to, it is 3 by 2 into x to the power 1 by 2. That means square root of x dx is equal to dt. So then what we are going to get out of it here, this is equal to, it is 3 by 2, so dt dx equal to, it will be 2 by 3 finally. That is 2 by 3 I can take outside. Square root of x dx is equal to dt. Now in the denominator, what you get is that square root of a cube minus x to the power 3 should be equal to t square, na? Correct or not?
Yeah.
All of you got it? So this is equal to 2 by 3 integration dt divided by square root of, we know the formula for a square minus x square or a square minus t square. But what about a cube minus t square? Not a big deal. We'll make it in the form of t square. How? We'll write a to the power 3 by 2 power square. That is a cube, na? Minus t square. So as if, a to the power 3 by 2 is our new way, kind of. And we know the formula for it. What is the formula? If you recall, square root of a square minus x square is equal to sine inverse x by a. So it will be sine inverse of t by a to the power 3 by 2 plus c, where c is integrating constant. Correct or not? Now, what is the value of t? That you need to apply back. Correct or not?
Yeah.
So, t is nothing but x to the power 3 by 2. So, what we can write? 2 by 3 into sine inverse x by a power 3 by 2. Correct or not?
Yes.
Correct? Plus c. And that is the answer. If any one of you is having any difficulty to understand, please do let me know. Otherwise, we can proceed to the next question.
Yes.
Okay, sure. Next question will be available to you another few seconds. So Sagnik, I want to know from you, what is your approach to solve that one?
So I didn't get how to do this question.
Yes,
Okay.
sir, same here.
Yes. So even we imagine it.
Okay. Okay. So let's discuss. Okay. Thing is that this is not, very, very easy question, and also not is too difficult at the same time. So first thing is that as you see there is sine 2x, one thing you need to make sure that I need to express something in terms of, sub multiple angle, that means sine x cos x. But how to do this thing? We know that sine 2x is nothing but 2 sine x cos x. Correct,
Yes.
dear student?
Yes.
Okay. So what will be the approach? Again, you just need to think 2 steps ahead, not 5 steps ahead. And the simplification of both trigonometry and little bit of integration. Because our target should be, in denominator we will get something in sine and cos whose differentiation should be sin x plus cos x. Are you getting my point? Whose differentiation is sin x plus cos x? It is sin x minus cos x differentiation is sin x plus cos x, not dear students.
Sin x minus cos x. Yeah.
Sin x minus cos x, if you get something na,
Yes.
in the denominator, then its differentiation is sin x plus cos x.
Yes.
So in back of our mind, I'm just striking up, in back of our mind, our target should be how I can express in the denominator in terms of sin x minus cos x, if possible. That is a very valid thinking, na? So I just want to concentrate on the denominator part, nothing else. And what is my target? My target is that how I can express the denominator in terms of sin x minus cos x, if possible. But I think it could be possible. Why? Because we know that sin 2x is equal to 2 sin x cos x, correct or not?
Yes.
So this is 16 into 2 sin x cos x. Cos x. So that is equal to, we are getting 9 plus, 16 into 2 sin x cos x. Correct? So what we are going to write is that 16 here, as our target is to express in terms of sin x minus cos x, so we can write sin square x, right? Are you getting my point, what I'm talking about? So what I'm going to write is that, I'm going to write here is that sin x minus cos x whole square. Let's see what will happen.
Oh, okay.
Sin x minus cos x whole square. If we write sin x minus cos x whole square, what is sin x minus cos x whole square? Sin square x plus cos square x minus 2 sin x cos x.
Yes.
Now, as minus 2 sin x cos x, so better let me, okay, just a minute, better let me remove this thing and here let me bring minus. Then what will happen? Sin square x plus cos square x minus 2 sin x cos x, which will come up here, no?
Yes.
Correct or not?
Yes. Yes.
So now, as it is minus here, so, in simple term, I can say like this thing, if someone is getting, little confused. So I am writing here minus 16 of minus 2 sin x cos x. Then it is fine, na?
Yeah.
So what I am going to write from here? 9 minus 16. Here, minus 2 sin x cos x is there, na? So what I am writing is that sin square x plus cos square x minus 2 sin x cos x and minus 1. I hope all of you got it. Because sin square x plus cos square x is 1, na? Now,
Yes.
as I introduce that 1 in the form of sin square x plus cos square x, so I should subtract. That's why this minus 1 is there at the end.
Okay. Yeah.
But what we are going to achieve by means of this? So 9 minus 16 into here we are getting sin x minus cos x whole square, na? Sin square x plus cos square x minus 2 sin x cos x, that is sin x minus cos x whole square,
Yes.
and minus 1. All of you agree to me?
Yes.
So now this minus 1 multiplied with minus 16 become plus 16. And that plus 16 when we add with 9 become 25. Correct or not?
Yes.
So we get 25 minus 16 into
Sin.
sin x minus cos x whole square. I just want to revert back in few minutes back what I said. I said that if I can bring the denominator in terms of sin x minus cos x, then my 80% of my problem is solved, because I know the differentiation of sin x minus cos x is sin x plus cos x. Correct? So then what I get? Let me use the different color pen. So from here, finally we'll get this is equal to integration sin x plus cos x dx divided by, instead of 9 plus 16 sin 2x, I am writing 25 minus 16 sin x minus cos x whole square. Correct or not?
Okay. Yeah.
So now let's assume that sin x minus cos x equal to t. That implies actually sin x differentiation is cos x. So cos x and cos x differentiation is minus sin x. So that minus will multiply with minus become plus sin x.
That's it.
Dx is equal to dt. Correct or not?
Yeah.
So finally we get what? We get this is equal to integration dt divided by 25 minus 16 into t square. Now it's very simple, na?
Yeah.
What we will do? We'll take that 16, common. Then what we'll get? If we take 16 common, then it is 1 by 16 integration dt by 25 by 16, that is 5 by 4 whole square. 5 by 4 whole square. Or we can do one thing, we can do, little, the other way also. There are multiple ways we can do. So this is equal to, we can write integration dt divided by, as 16 is there, na, is the perfect square. So 5 square minus 4 into t whole square. But here we need to make a small substitution. That's it. Small that you can do in your. And what we are going to get is that from here is that, if you recall that what is integration, dx by a square minus a square? Tell me. 1 by 2a, na? So if you do this thing, finally you will get 1 by 40 into, because on that we need to assume na 40 equal to z, another substitution. Got it or not?
Yes.
So then you will get 1 by 40 after applying that substitution. That you can do in our mind. For that you don't need to make another substitution. Are you getting my point, all of you?
Yes.
Divided by 5 plus 40
Yes.
plus c. Correct or not?
Yes.
So from here, what we are going to get, we need to revert back the value of t. What is the value of t we took? It is sin x minus cos x. Correct or not?
Yes.
So that we are going to revert back. So what we are finally going to get, the value is 1 by 40 into ln. It is 5 minus 4 into sin x minus cos x divided by 5 plus 4 into sin x minus cos x. Any simplest difficulty? Sagnik, is it fine? Dear
Yes,
sir.
sir.
Gurman, Divansu, Disha, Srijita, Mohor.
Yes. Yes.
Absolutely clear? Okay, now we
Yes.
can proceed to the next question. So if you see, I gave a different varieties of question. Why? Because in your examination, you will get this kind of questions, and then you can always map. Yeah. These are the things we discussed with Sir and this thing. Now the next question I am bringing. Yeah, this is question number 6. Okay. If someone of you already approached that one, I would like to know that how you have approached this one.
So I divided numerator and denominator by x squared.
Fantastic. That is the right approach. Very good. After that,
After that, like I got 1 plus 1 by x squared plus 1 plus 1 by x squared. After that, I tried expressing the denominator in the form of a whole square.
so what is your final answer, by the way? Good. Your approach is correct.
I got 1 by root 3 tan inverse of x minus 1 by x by root 3 plus c.
Okay, let's see. Okay,
And
let's see. Okay. Anyone else? Divansu, Gurman, Disha, Srijita, Sagnik, anyone?
I didn't get this one, so.
You didn't get
So I
this
didn't
one?
get.
Soon I didn't get.
Okay. So here the approach is that, as Mohor correctly suggested, that we should divide both numerator and denominator by x square. But why? Why you should divide by x square? Because in the denominator there is x power 4. Again, 2 steps ahead. Okay. Think about 2 steps ahead. 2 steps ahead, if we divide both numerator and denominator by x1 x square, so then what will get? It will, in the numerator you will get 1 by 1 plus x square. Correct, na? Dx divided by, in the denominator we will get x square minus 1 plus 1 by x square. Dear Disha, is it perfectly fine?
Yes.
Okay. Now what we are going to do is that in the denominator, if you look into the denominator very carefully, okay, you will get some a proper pattern. Is that we can write this is equal to x minus 1 by x whole square, na? Correct or not? Why x minus 1 by x whole square? Why I need to express the denominator in terms of, let me use a different color. These my target to express these things in the form of x minus 1 by x. Why so? Because its differentiation is actually 1 plus 1 by x square. Are you getting my point, dear students? Sagnik, Gurman, Disha, got it, no?
Yes, sir.
Okay, so this is your back of your mind. So that's why I'm just striking off that, yeah, I need to bring something like this. Now, how to bring that one? And that is quite a very simple algebraic simplification, algebraic operation. You write whatever is there in the numerator, 1 plus 1 by x square into dx. And in the denominator, what I'm writing is that, x minus 1 by x whole square. First, I write x minus 1 by x whole square. Why whole square? Because everything is square. X square plus 1 by x square. Then what happened? Then we write here is that if you see a minus b whole square is equal to a square plus b square minus 2ab, na? Correct or not? So here we need to bring plus 2ab plus 2 into x into 1 by x. Correct or not? And minus 1 as it is. Correct or not? Absolutely clear, dear students. So I think Mohor, you got actually, little bit lost after this step. So what happened is that 1 plus, and at that I conclude after hearing your answer. 1 plus 1 by x square dx. So that become 1 plus x minus 1 by x whole square. All of you agree to me? Now we'll make a substitution. Let me use a different color. So what is the substitution we are going to do?
Sir, I put minus 3, that's why. Okay.
Why you put minus 3? That was a silly mistake, right?
Yes.
So let x minus 1 by x equal to t. That implies what? It is 1 plus 1 by x square into dx is equal to dt. And that value we are going to apply here. So what we are going to get then? So this is equal to integration 1 plus 1 by x square dx is equal to dt by 1 plus t square. Correct or not? Dt by 1 plus t square. All of you know it is actually tan inverse t plus c. Correct or not? So this is nothing but that is equal to tan inverse t plus c, where c is integrating constant. And as you know that we need to get back the value of t in terms of x, that is x minus 1 by x plus c, and that is the answer. That you can write x square minus 1 by x, that's also fine, it is also fine. Correct? So I think we can proceed to the next question if there is no further query here.
Yes.
Okay, question number 7 will be available to you in few seconds. Okay, Gurman, I want to know what is your approach?
Sir, I didn't get this one.
You didn't get this one? Okay. Mohor, what is your approach?
No, even I didn't get it, sir.
Divansu, Disha, Srijita, what is your approach?
I didn't get this one, sir.
Okay. All right. So let's see. Here also, we need to, brings that x power 4 what you see in terms of x square. And this is little tricky question. This is not a very straightforward question, and it needs not only two steps ahead, you need few more steps ahead to find the solution. So I think you have some time now. If I can extend the class for some more time, no issue, right?
No.
Yes.
Okay, fine. So that I want to complete all the assignments what I gave yesterday, hence this request. Okay, so what we're going to get it is that, in the numerator, I want to bring, x square plus 1. Okay. So if I need to bring x square plus 1, so what you need to do? So notice it very carefully, the steps I'm following. So what I'm going to say is that we are writing here something like this: integration is 1 plus x square. I'm writing. If I'm writing 1 plus x square, then again I need to write minus of x square minus 1. Why I'm writing, I'll explain after some time, after a few minutes. Divided by whatever is there, x power 4 plus 1 plus 5x square. Now, if you see in the numerator, I have introduced 1, 2. So, to nullify, I need to make 1 by 2. Correct or not?
Yeah.
Sure. That becomes two separate integration. One integration is that 1 by 2. Integration 1 plus x square divided by x power 4 plus 1 plus 5 into x square dx minus 1 by 2 integration x square minus 1 divided by x to the power 4 plus 1 plus 5x square dx. Correct or not?
Yeah.
Now, after that, it is a similar approach what we did for the previous one. You should divide both numerator and denominator by x square. And to do that, I have done that, first step like this. Introduce 1 plus x square and x square minus 1. So this equal to what? 1 by 2. As we are dividing both numerator and denominator by x square. So what we are going to get? 1 plus 1 by x square.
Yeah.
1 plus 1 by x square divided by x square. Correct or not? Plus 1 by x square plus 5 dx minus 1 by 2 integration 1 minus 1 by x square divided by x square plus 1 by x square plus 5 dx.
Yeah.
So we get two separate integration. Okay, correct or not? One integration is the integration of 1 plus 1 by x square plus 1 by x square plus 5 dx. Correct or not? So
Yeah.
what we are going to do is that we are writing these two as two separate integration. Okay, so what we are going to get is that, so this is equal to 1 by 2 into I1 minus 1 by 2 into I2. Correct? Where I1 is equal to integration 1 plus 1 by x square divided by x square plus 1 by x square plus 5 dx. Correct or not? And I2 is equal to integration 1 minus 1 by x square divided by x square plus 1 by x square plus 5 dx. Correct or not? Now the point is that I do not want to proceed further because similar problem we have done for the previous question. That for the I1 integration, you need to make sure that you need to express the denominator in such a way in terms of x and 1 by x that its differentiation should be 1 plus 1 by x square. Got it, na?
Yeah, I can make it in the form of whole square.
Yeah, so x minus 1 by x something. Correct, na?
Yes.
And for the second one, you need to express the denominator in such a way in terms of x so that its differentiation become 1 minus 1 by x square.
Yeah.
That also you can do. That is all algebraic simplification. Is it clear, all the students, dear? So that, I do not want to proceed further here because you know how to do this thing, right? Because the similar problem we have done for the previous one, right? Gurman, Sagnik, Devansu, Srijita,
Yeah,
Deep.
sure.
Yeah.
Yes, sir.
All right. Then I should proceed to the next question because it is better to spend time on a different varieties of question, or not the same question I'm doing. If you got stuck, please do let me know. Never hesitate. Huh? Okay. The next question, it will be available to you in another few seconds as I gave yesterday. That is the 8th question, dear student. Okay. I would like to know what is your approach. Anyone can start saying this thing.
So we take the sine square x plus cos square x whole power square minus 2 sine square x cos square x.
After that,
It becomes 1 minus 4 sine square x cos square x by 2.
after that,
I take 2 minus 4 sine square x cos square x by 2. Then I take out the constants out. Becomes 8 into integration dx by 2 minus sine square 2x.
oh, I got your point. I understood. See, there is a simpler approach. Anyone wants to say before I start giving you the idea?
So
Yeah,
I
please.
divided numerator and denominator by cos to the power 4x. After that, I got 4 sec to the power 4x by tan 4x plus 1 dx.
Very good. Right thing.
I
Appreciate.
I took the constant 4 out, then sec square x into 1 plus tan square x dx.
Fantastic. Fantastic. Very good.
Yeah, I got till there. My getting till there was this method.
Yeah, it is exactly. That's what I said. That you could achieve in little smaller steps. That's what I wanted to say. Now, anyone, Gurman, Sagnik, Disha. So the approach should be something like this: is that very well said. Okay, but how to proceed? Let's take 4 outside. So as we do not know that sine power 4, as you very correctly said, Mohor, that I divide both numerator and denominator by cos power 4x. Okay, then what you get? You can take that approach, or you can say that I can make the numerator as sine square x plus cos square x, and then I will divide. In that way also you can think of it. Okay, so now why it is dividing by cos power 4x? So 4 by cos power 4x means 6 power 4x. And sin power 4x by cos power 4x is equal to 10 power 4x. And cos power 4x plus by cos power 4x is 1, that is dx. You know, the moment we come up to here, 30 to 40% of the problem got resolved, because we know that if we take tan x equal to t, we'll get sec square x dx equal to dt. The only thing we are remaining is that only you need to bring sec square x. So another sec square x we can write is that 1 plus tan square x. Correct, no?
Yeah.
And another sec square x, as it is, I am writing sec square x dx divided by 1 plus tan power 4x. All of you got it, dear students? So now our substitution come into the picture. Our substitution here is that let tan x equal to t. So from here what we get?
6 square dx.
Sec square x dx is equal to dt. And that value we will apply here. And what we'll get? If we apply that value here, you will get 4 into integration 1 plus t square divided by
1 plus t to
1 plus t to the power 4 dt.
Yeah.
See, a trigonometry which integration of a trigonometric function has been transformed to an integration of an algebraic function by means of substitution. Now after that, you know better than me that I need to divide both sides by t square, because similar problem we have done. Correct or not?
Yeah.
So what you'll do? You'll do 4 integration 1 plus 1 by t square. 1 plus 1 by t square divided by t square plus 1 by t square. Correct or not?
Yes.
Now again same thing, the denominator, that t square plus 1 by t square you need to express in such a manner in terms of t and 1 by t, so that its differentiation become 1 plus 1 by t square, and that is the only way to do is that t minus 1 by t. Correct or not? And that you can always do by means of a plus b whole square is equal to a minus b whole square plus 2ab, all these things. Correct?
Yeah.
I do not want to proceed, and it is a very valid justification why I should not proceed right now for this question.
Sir, after that, shouldn't we take one more like substitution? Like 2t minus 1 by t equals to u after that.
Obviously, you take that is equal to z. Yeah, you can take multiple substitution. Shall I do it? If you want, I can do it.
Sir, after that, I took t minus 1 by 2 t equals to u.
Ah, correct. So then 1 plus 1 by t square dt is equal to du. So integration du by u square plus 2.
Yeah, so like finally I got 4 integration of 1 by u square plus 2 du.
Correct. So then, see, the moment you get in integration of du by u square plus 2, then you know what to do. Sorry?
The formulas that like
Formula that you need to say, instead of doing integration dx by x square plus a square, 1 by a into tan inverse x by a. Why you are asking me?
So half 1 by 2 tan inverse of u by a plus c.
Yeah.
After that, substitute t and substitute that
value. Exactly, correct.
Oh, okay.
Absolutely. There is no, whatever the statement you said in the last 1 minute, it is just, we are just repeating, but it is straightforward. Absolutely. If you make t to z or t to u, obviously you need to replace back by t and then finally t to t by x, that is tan x.
Yes, I got it.
Okay, so let me go to the next question. Okay, this is question number 9, dear students. What was your approach? Anyone?
So I didn't know how to start this.
Yeah, same here.
Okay, so this kind of question we will um, discuss in details later, but I can give you a little bit of hints that how you can proceed. But there is proper way of making a proper substitution. So thing is that here also, if you look into the denominator, one you know question we have done today, where denominator was sin 2x. So your purpose should be the denominator to be expressed in terms of sin x and cos x, na? But unfortunately, okay, in the numerator the only given is that cos x, 2 cos x. Unfortunately, it is there cos x, and fortunately, it is there 2 cos x. Both the statement actually makes sense. So what we are going to do, we are going to write the numerator as a cos x plus sin x plus cos x minus sin x. Correct, na, dear students?
Cos x plus. Okay.
So what I'm going to say is that something like this. So this is equal to what I'm going to write is integration 2 cos x. So cos x plus sin x. Correct? Plus
Cos x minus.
cos x minus sin x. So that actually makes that intact the numerator value, that is 2 cos x. And here what we are writing 3 plus 4 into sin 2x. Sin 2x is what? 2 sin x cos x. So that we can write, I'm just making one step jump, 1 minus sin x minus cos x whole square. And that is okay for this step jump, because you know why it is. Because sin square is sin x minus. You can do this, you will find it out. That's a big deal. Correct? Then what we are going to do is that we are making it a two different integration. Correct, na? So what is the two different integration we are getting here? The first one we are getting is that cos x plus sin x, because if you look in concentrate on the denominator, that sin x minus cos x, that sin x minus cos x differentiation is nothing but cos x plus sin x. So I'll write here cos x plus sin x. Cos x plus sin x dx divided by 3 plus 4 into 1 minus sin x minus cos x whole square.
Yeah.
Correct, na, dear students?
Yes.
That is the first one. But if you take sin x minus cos x, its differentiation is cos x plus sin x, but its differentiation is not cos x minus sin x, na?
Yes.
So what to do? We'll make that for the second one, the denominator will change little bit. What you will do? Here, what we are going to do is that, notice very carefully, it's a big integration. So here it is cos x minus sin x dx. Now tell me whose differentiation is cos x minus sin x? It is sin x plus cos x differentiation is cos x minus sin x, no?
Yes, yes.
So our target should be that sin x minus cos x to express in terms of sin x plus cos x. And that can be easily done. What you can write? 3 plus 4. We can write here is that sin x plus cos x whole square minus 1. Notice it.
Okay. Yes, yes, we can do that.
Correct, na, dear students? So now we get two different integrations. First integration is cos x plus sin x. This is the one. Correct? And the next one is that this one. For the first integration, you know what you need to assume. For the first integration, you should assume this is equal to t. Correct or not? And proceed. And for the second integration, you should assume this is equal to u and proceed. Correct or not?
Okay.
And after that, it is pretty simple. After that, it will be, transformed to a algebraic function. And then proceed. Got it or not?
Yes.
Please do send me your workout by, end of the day today, so that I can look into it. And tomorrow we will, start a new topic called integration by parts. And dear students, so your task for today is that you need to start working on the 2 more DPPs. Thank you very much for each one of you, those who have submitted their DPPs. Okay, so you need to solve 2 more DPPs after that. Okay, that is the task you have for today. And yeah, please. Yes, Dibansu or someone is saying? Okay, all right. So if you do not have any further question, then we can conclude the class for today. Correct?
Yes.
All right. Thank you very much.
Thank you, sir.